All right, so let's go over these answers. Just some review. You guys have been working on them for a little bit. What is the equation of a circle? Very good. So make sure that you know how to write. Sorry. Thanks. Make sure you know how to write the equation of a circle, how to graph the circle, and how to, write it given a point and a radius and a center. Okay, question 2. Central angles have a vertex at the blank of the circle. Center. The measure of the angle is blank to the arc. Equal. Inscribed angles have a vertex blank the circle. On the circle. So it's going to be somewhere on that outer rim on the arc. And the measure of the angle is blank the arc. Half. Now, I want to talk about these two real quickly, and I have some manipulatives here, and if you want to, you can kind of draw these if you want, but I wanted to show them to you. So, let's say that we have a circle here. Whoops. Let's say that we have a circle here, okay? And let's say that I wanted to split my circle into fourths. I wanted to take a fourth out of my circle. What would that look like? You'd make a little box in there, right? If I wanted to cut my circle and take a fourth out, I would do like that. How much is fourth of a circle? It is 25%, right? It's a fourth. It's 25 if we're talking about 100. How much is it in terms of degrees? It would be 90 because in a circle, all the angles add up to be 360. If we take a fourth of 360, we get 90. Now, this angle right here is also 90. So that's why these two are the same. So when you are concerned about central angles, think about this picture here and think about if you split it up into fourths. And I just look at this fourth piece right here. This is 90. So this arc is also 90 because I split it up into fourths thinking about degrees. Now, what would happen if I took that piece off in the middle, that vertex off, and I moved it over here to the side, so now it looks like this? Is that angle still 90 degrees? No. So now we have the vertex, instead of being here in the middle, I'm going to leave my intersection point up here, but I'm going to take that vertex and I'm going to shift it here, which means this line is going to stretch out. So what happens to that angle? It gets cut in half. So that angle is now 45 degrees. So that's why I wanted to kind of show you this as a little demo. So if I take that angle and I shift it over, now it's going to look like this. That angle is going to get smaller. It's kind of like you stretch that part out. So that's why angles at the center are the same. Angles on the circle are going to be half that arc because it gets stretched back. All right, question 4. A tangent is blank to a radius or diameter. Perpendicular. And perpendicular means what kind of degrees? 90 degrees. In this last picture, how is this angle 1 related to angle 3? They're supplementary. What does it mean to be supplementary? Good. You add them up to equal 180. Very good. All right. The rest of your notes I have printed for you so that way you don't have to draw those circles down. So let me pass these out real quick while I change boards. Oh, it did change quickly. Don't go fast. So instead of a packet today, yes, we just have one piece of paper. All right, guys, let's not go crazy. Let's get our lesson done. Okay, so this one is saying, what if we have an angle somewhere inside the circle but not at the center? So here we have angle 1. It's just floating around inside that circle. That angle is half the sum of the intercepted arcs. So angle 1 equals 1/2 the sum. What does sum mean? What math operation is sum? Addition. We're going to add our arcs together. So the angle equals 1/2 arc plus arc. You add the two arcs up and it makes the angle. And the reason is dealing with vertical angles that we talked about the other day. So if this is angle 1, if I were to trace it out, it hits the circle here and here. So it intercepts arc X, doesn't it? But we could put angle 1 in another spot because of vertical angles. We could put angle 1 right here. So that means we could also trace it out this way. So it hits our circle here and here, which intercepts arc Y. So we kind of have to do the average of those two arcs. We add them up and divide by 2, or add them up and take half of them. So if an angle is somewhere inside the circle but not at the center, we do half arc plus arc. And here's another way to remember it too. Some people get confused about what to put in here, but if you draw an arc in the air, it's curves, right? What else have curves? Parentheses, so your arcs go in the curves. Key thing. All right, let's look at our next problem. This next one says if you have an angle outside the circle, then that angle is half the difference. What does it mean by difference? Subtraction. So your angle equals 1/2 arc minus arc. Now, I drew 3 different pictures here because angles outside the circle could be made up of different lines. If angles are inside the circle, they're made up of 2 chords. We see those 2 chords cross, right? Not the diameter, but any other chord will work for this. So inside the circle is 2 chords. Outside the circle is different types of lines. What type of line is this one and this one? How many times did they touch the circle? Twice. What are they called if they touch the circle twice? Got to do some more review on those terms. Starts with S. Secant. There we go. That's it. So this one is made up of 2 secants. We write it above. Now this one is made up of a secant, but also a tangent. And this last one is made up of 2 tangents. So our picture could be different based on what we have. Here we have a secant and tangent. And then here we have 2 tangents. So you might see 2 secants, 2 tangents, or the combo. But either way, the formula is the same. It is 1/2 arc minus arc. All right, so the rest of what we do today is we are going to just look at examples of these different ones that we have. So let's go with our examples. Here is the first one. Now, here's what I ask myself on every single one of these questions. Where is the angle? Which one is the angle? x. And x is located where? In or out? In. So if it's located on the inside, use the equation. The angle equals 1/2 arc plus arc. So my angle is x, and it equals 1/2 80 plus 20. What is 80 plus 20? 100. And half of 100 is 50. So x would be 50. I put that other picture a little too close. Now, the reason that that works, again, is think about kind of like what you trace out. If this is angle X, we could do it like vertical angles. And so it hits here and it hits here. So those are the two arcs that you go with. Okay? Kind of makes that X shape. Look one way, look the other way. Now, we would do the same with this one. But here is X. If I were to trace out X, it hits this arc and this arc, doesn't it? Is that the arcs that we know? No. So what you can do on a problem like this is you can throw in an additional letter. Let's call this one Y right here. And now if we find Y, it's going to find the arcs that are on the left and the right. So we're going to set up the same equation. The angle equals 1/2 arc plus arc. So what's 160 plus 60? 220. And half of that is 110. So that means angle Y here is 110. Now, use your idea of vertical angles. So you could put 110 there, but you could also put 110 on the other side. How can that help us find what X is? You could subtract it by 360 and divide by 2 because all four of those right here in the middle should add up to be 360. What's another way? If all four of them add to be 360 and two of them are the same, you could just subtract it from 180. These two are what we call from math 2 a linear pair, or they make a straight line. So x plus 110 makes 180, so x would be 70. So make sure you're finding the correct angle. So if you find the opposite angle, subtract it from 180 and you get your other angle. Exactly. That's another way of doing the problem. I'm glad you thought about another way. You're right. So just to explain it for people at home who have the video, if you subtract these two from 360, you will get these two arcs together. And that would be the whole sum there. And you take half of that, and that will give you your angle. So yeah, that's another way of thinking about the same problem. That would be perfect. Because if we did subtract 160 and 60 from 360, we end up with 140. And what's half of 140? 70. So either way you want to do it is fine. All right, flip your paper over and you will see problems 3 and 4 here. Now, where is the angle? Outside the circle. So now that it's outside, the angle equals 1/2 arc minus arc. Now, our angle is called X. When you do your two arcs in your parenthesis, you do the arc furthest away first. So what's furthest away? And then you minus the closer, 92. The reason that you do this is so that way you get a positive answer. If you notice on the first slide there, it said always make a positive angle. The only time you're going to make a negative angle is if you reverse these numbers. So it should end up being a positive number for all that you do. All right, let's subtract them. So what's 268 minus 92? 176. And then half of that would be 88. All right, let's go to problem 4. Now, first, is this an add problem or a subtract problem? This is an add problem because the lines, we got 2 chords and they're in the circle, right? So this one is going to be angle equals 1/2 arc plus arc. Angle equals 1/2 arc plus arc. But in this case, which one is the angle? 94. It's not X, is it? This is my angle because it's made up of lines. What is X? It's an arc because it's a curve. 112 is an arc. So we're going to write our formula as 94 equals 1/2 X plus 112. So don't get in the habit of just saying X equals. Sometimes that X might be an arc, so it needs to be inside the parenthesis. What would we do to solve this problem? You could distribute that 1/2, but if you distribute it to 112, don't forget to distribute it to X. What else could we do? Could we do something with the 1/2 and get rid of it first? Multiply by 2. That's how I like to start these problems. If you multiply both sides by 2, it's going to cancel out that 1/2. And so on the right side, we're just left with X plus 112. And that might make your math a little bit easier. So let's double 94 and we get, good. And then subtract 112, we get 76. So a little simpler thing, if you're trying to find the arcs, multiply by 2 by that angle, and then just add or subtract the arcs that you have. All right, question 5 will show up in just a minute. But how do you feel about these angles? Not too bad? That's great. You okay? Okay. All right, sorry my board's decided to freeze. Oh, there it goes. Okay. Now, think about where the angles are. Do we have 2 chords where it's inside, or is this one outside? This one's outside. So if it's outside, the angle equals 1/2 arc minus arc. So what's my angle? X equals 1/2. Go furthest arc, closest arc. Good. 160 minus 68 is, and then half of that. Good job. All right, let's do problem 6. Problem 6 looks similar, right? So tell me the equation I need to write for problem 6. Good. So X equals 1/2, and then parentheses we would put 130 minus 30, arc minus arc. What's 130 minus 30? 100. And half of 100 is 50. Now, question 7 has an additional line in it, but still go with the same thing. Do you see the same kind of picture as you saw in the last 2? Yeah, especially if you just ignore this line at the bottom with y on it. So if you just kind of take that part off, right, it's the same as these. So do it the same way. Now, don't mark it out completely because we're going to have to find that later. But let's just start off the same way. We're going to do the angle equals 1/2 arc minus arc. So I heard y'all already saying it. So 50 equals 1/2. What's going to go in that parenthesis? Very good. Let's start off by multiplying by 2 to make our math a little bit easier. So 100 equals 160 minus x, because it just cancels out the 1/2. Then we would subtract the 160, so we get negative 60 equals negative x, so positive x must equal positive 60. And now let's look at y. That's our next part that we need to find. Y is an angle, right? Because it's made up of these two lines right here. This line and this line. Bless you. Now, think about that angle. Is it inside the circle? Is it outside the circle? It's on the circle, right? So look back at your notebook paper that we did at the very beginning. What do we do if an angle is on the circle? The angle is half the arc, because this now is not just our regular old angle. This is now an inscribed angle. That angle y is an inscribed angle, so it is going to be half the arc. Now, it's going to be half the arc that it intersects. So if I were to trace this out, it intersects this arc right here. Do I know the value of this arc? Nope. Let's put a variable on it. Let's call it z, because we can find what z is. In a circle, all the arcs add up to be 360. So I know that this top arc is 160. And then I have arc x, which I found to be 60. And then I have arc z. So all three of those arcs should add up to be 360. So let's add those up and then subtract from 360. So z would be, now if that arc is 140, that angle is 70. It is okay to throw another letter in there to help you figure out what that missing part would be, but that's going to be our inscribed angle that we need. Okay, here's our next to last problem, because we are going to do one additional problem after this. But here's our next to last one. Okay, which formula are we going to use for this one? Good. Angle equals 1/2 arc minus arc, because we have some stuff outside the circle. Now we know the angle. The angle is x, and we know one of the arcs. We know the closer arc is 120. Do we know the furthest away arc? How are you getting 240? Yes, we are assuming here that we have some tangent lines, right? And if we have tangent lines, they only hit the circle once. So to find this missing part of our arc, we would do 360 minus 120, which would give us 240. So 240 is the arc that we're missing. So if you are missing an arc measurement, remember, do 360 minus the other arcs, and that will give us our missing arc. So let's finish solving this problem. So x equals 1/2. What's 240 minus 120? And half of that is 60. Okay, I'm going to give you one more problem. This one is very similar to a homework problem that you have. So there's probably not room on this worksheet. There might be some room on the front maybe. But if there's not any room, just put it on the notebook paper that you just did. Just don't forget that it's there. Now it's going to look very similar to this picture that we just did. So I'm going to draw in 2 tangent lines. That one should touch. Okay. And I'm going to use Luke's favorite number and say the angle is 67. But I want to find this arc, which is x. So if we set up the same type of thing, the angle equals 1/2 arc minus arc. My angle is 67. I don't know this outer arc, but I know the inner arc is x. How can I find the outer arc? Noah, you got an idea for us? Nope, you can't multiply by 2 to get x because you could do that if it was an inscribed angle, if it was on the circle, but this one's outside the circle. Think back to the previous problem that we did. We were also missing an arc up there. What did we have to do? The 2 arcs should add up to be 360. So to find that missing arc, we did 360 minus 120. We can't use 67 because it's not an arc. That's what we use. That missing arc right here is going to be the same as the work that we did here. This is going to be 360 minus x because we have to minus the closer arc, not the angle. Some people like to do 360 minus 67, but that's an angle. All the sum of the arcs are going to add up to be 360. So in this spot, we're going to have 360 minus x. And then we have to minus x again because that's the closer arc. Does that make sense? So it's arc minus arc. Okay, so let's put that together like we did last time. We could go ahead and times both sides by 2 to get rid of that 1/2. So what's 67 times 2? Now, these we can combine like terms. So that will bring up that 2 that y'all were referring to. Is it double? That's where the 2 comes from because it's subtracting both arcs that we have. And so to solve this, we would minus 360. What's 134 minus 360? 2 what? 217? Okay. 226. Okay, that sounds better. And then we would divide by -2, and we get, and that would be our x. All right, so here is your homework. Now, I am going to stop us at about 10 after in about 25 minutes because we're going to put everything together. Technically, you could. Yeah, you could use the 1/2 since there's 2 negative x's there. And, yeah, that would shorten some things up there. Yep, you could do that. Okay. So I'm going to pause this video. I'm going to come back and give y'all one. Hold on. Then we're going to do the last. Okay, so next we're going to make a little foldable talking about all the different angles that we've talked about this week. So if you don't want to make the foldable at home, you can just make it into a chart. But not you guys. Y'all are making the foldable. So on the front, you guys are going to write these 6 things here on the left side, starting at center. It's the location of the vertex, and then going down to intersection of tangent and chord. Those are your 6 sections that are on the front. And then you can go ahead and draw this picture. Now, we're going to put more things in the picture, but there are 6 circles and 6 terms that you need. So we're going to talk about the location of the vertex. We're going to have a picture, and then we're going to write down what the measure of that angle is. So I'm going to give y'all a minute or so to do that, and then we're writing the rest. Did you see that? Okay. I'm going to go ahead and start drawing these things and writing them down because we got about 10 minutes left of class. So I want to make sure that y'all get this copied down in these next 10 minutes. So I'm going to zoom in on this, and then I'll zoom back out so you guys can write the rest. But let's draw a picture. So if the vertex is at the center, we call that a central angle. So I'm going to draw a picture of that. Here is my angle. I'm going to call it angle 1. And then I have my arc, which is labeled as X. So my angle will always be angle 1, and my arcs will be X or Y. So if the vertex is at the center, now think about this picture where we did at the very beginning of class where we did like a 1/4. How was this angle measurement related to this arc? It was equal. That's right. Angle 1 equals X. The angle equals the arc. So when you're doing your flap here, you lift up the flap, and that's where you write angle 1 equals X, angle equals arc. So if the vertex is at the center, then the angle equals the arc. Okay. What happens if the vertex is touching the circle where it's an inscribed angle? So that's where maybe we have an angle that looks like this. Here is angle 1. How is the angle related to the arc? It's half. The measure of angle 1 equals half the arc. Now remember, you could go backwards with this. What could you do to the angle to get the arc? Multiply it by 2. So twice the angle will give us the arc. Now the next 2 ones are what we did in class today. So what happens if we have an angle inside the circle? Remember, that's if we have 2 chords but not the diameter. So what do we do with our angle? Our angle equals 1/2. plus y. Yep. So the angle equals 1/2 arc plus arc. And if it's outside, what's the equation? What's different? Good. Now, when you draw this one for the outside, make sure X is the furthest one away. So, angle 1 equals 1/2 X minus Y, or the angle equals 1/2 arc minus arc. The next one we talked about at the beginning of the class, what do we have when we have a radius and a tangent? Radius and a tangent, perpendicular, that's right. And it could be a radius or a diameter. I'll just call this angle 1. So angle 1 equals what degrees if it's perpendicular? "90 degrees. We've got one last one. That's the intersection of any chord and a tangent. I have the hardest time drawing these, so you'll have to forgive my drawing. Angle 1 equals. Now, this one, notice it's an intersection of a tangent and a chord, but still, where is the vertex? It's on the circle. So if it's on the circle, then it is half the arc. So the angle equals 1/2 arc. No, not just 1/2 arc. I was going to put minus arc. Just 1/2 arc. Or you could go the opposite way. Double the angle and it equals the arc. So if you notice, I'm going to shrink this a little bit so you can see the whole thing, but if you notice this one, the intersection of the tangent and the chord is the same as touching the circle, because touching the circle means the vertex is on the circle. It's just used with two chords here or a tangent and a chord here. So those two are exactly the same. Now, what do you guys have tomorrow? A quiz. And that's pretty much the only thing that we're going to do tomorrow, except the last 15 minutes I am going to go over your roller coaster project, our big project for second quarter. But again, you got about a month to do that. So we'll do that tomorrow and take our quiz. But know everything that we did this week. So don't forget to review Monday's lesson about the equation of circles. Tuesday we had parts of the circles like secant, tangent, chord, identifying those. And then we had some stuff with some isosceles triangles and right triangles because of the tangent lines. Then yesterday with our inscribed angles and central angles. And then today with our angles that are inside the circle and outside the circle. Guys, we still got actually 4 minutes before y'all leave. So make sure you get this copied down. Maybe you can do one more problem as well. Yes, Noah?